Welcome back to iOS YouTube channel. Now, in this video now, we're going to be looking at Hicksian and compensated demand function. Like I explained in our previous video that Hicksian is an opposite of Marshallian. So if you look at this new function now, as this one that we are using as an example, you can see that the reverse is the case when we come to Hicksian. Now, it is now the expenditure function or the budget line function that is now our objective here. Now, then our constraints, which is subjected to, is now the utility functions. So do you get it now? It's not reverse, it's just they just reverse the function. Where in Marshallian, this is my constraint, but now in Hicksian, this is now my objective. So let's move on. Let's solve these Hicksian questions too. Don't forget that this is our equation 1 now. This is now our equation 2. Like I said that the step 1 always remains that you state your Lagrangian. So, and I said that the Lagrangian will always be represented by L. But now the case is different because our objective is this. So what will be the first thing to do is to drop this x, px of x plus py of y, then plus. This is the same thing like the previous one. It's going to be the combination of the objective and the constraint. But you are going to include the lambda. So now this one will now be the lambda. So then you put prime u, which is known as our utility, minus x, xy. So I know by now, if you watch the previous video of the Marshallian, you know the reason why we're having the xy, because we are going to take this one to this side, and equate it to the 0, and that's what we are bringing down here. So you watching the first video, which is the Marshallian, will make you to understand this. Please do if you have not. So this one will now be our equation 3. So this one will be our equation 3. So by doing so, the next steps that we have to move to now is 2, which is going to be the step 2. So our step 2 now is to use, using the first order condition. First order condition, which is known as what? FOC, first order condition. So by using the first order condition, where we are going to have, the Lagrangian dx equals to 0, the Lagrangian dy equals to 0, then the Lagrangian d lambda, which is also equals to 0. This is what the first principle, where we are talking about first principle, this is what we mean. So then, by doing that, let's find our Lagrangian dx, which is the partial differentiation. So the Lagrangian dx indicate that we are differentiating with respect to x. So if we are differentiating according to partial differentiation, this does not have x. Automatically it is 0. It's out of the game. Yeah, but this have x that we want to differentiate. So that means we are differentiating this x, you're having 1. 1 times p, then you're having what? P of x. Then let's move to this one. This one does not have x, it's automatically 0. Don't forget, you are multiplying this with this. Then you have lambda u bar. So you have it lambda the u bar, then it's going to give you 0 because it does not have the x that I want to differentiate. But this one has the x that I want to differentiate. And by opening the bracket, the negative sign will already affect it, which is going to give us minus here. So then this one will give us 1. 1 times y, you have what? Y. This is partial differentiation rule. So then this equals to what? 0. Then let's move to the next step. You have the lambda dy. So you're having the lambda dy, automatically you're having py minus what? X equals to 0. So don't forget that this x, because we assume that when we are differentiating for the lambda dx, we are having y. Don't forget that lambda is also there. So our lambda is also there. Please don't let us forget that. Lambda is also there. So because if you open the brackets, I want you to understand. Because before you differentiate, we need to open these brackets. So and by doing so, this one multiplied by this and differentiating this without x or y is automatically 0. Then you open the bracket with this one. That means this word here, this guy here is going to give you something like lambda x y. So if I'm differentiating with respect to x, that means I'll be left with lambda and y. If I'm differentiating with y, that means I'll be left with what? Lambda and x. Please note that, it's very important. That's why you have lambda y, lambda x here. So then the Lagrangian, the lambda, I will be having, u bar minus yx. You know that this is what you want to differentiate, just these two guys. And once you differentiate, you are going to get 1. 1 multiplied by this will still give you what is inside the bracket. Hope you are following. So now let's move to, don't let's not forget to give them the equation. This is equation 3, this is equation 4, this is equation 5, this is equation 6. So what we do now is to make, which is going to be the step 3. So step 3 now, make x, y, and u bar as the subject. So and by doing so, I'll be having px, px equals to lambda y, which will give me, y equals to px over lambda. We have made y as the subject. Now, then if this is equation 6, this will be equation 7. Sorry. Let me make this as equation 7. Equation 7. That's equation 7. So let's now move to the other equation, which is py, equals to lambda x, which is this. Py equals to lambda x. Then in this place too, we have x equals to py over lambda. So this will be equation 8. Then the last equation, another equation we have is, we have u bar, we now equals to what? Xy, which is going to give us equation 9. I hope you guys are following. So now, by doing this equation, the next thing is now to take the ratio. See, step 4. So take the ratio of equation 7 and, of equation 7 and 8. So we take the ratio. Then once we did the ratio of equation 7 and 8. So the equation 7 is y equals to px over lambda. Then this one will be over x. Then this one will be divided by py over lambda. You should understand that I don't want to put a fraction here so that you just move on to the solution. So let's clean this. Let's continue from this side. So in our continuation, we have y over x, which is going to give us px over lambda, which I can change to multiplication, and lambda will come up, then py will come down. This cancel this. Then, y over x will now give me what? Px over py. Then cross multiply, then y will be what? Px of x over py. So that is what we eventually get for y. That's what we eventually get for y. So we have not finished. So this is not the actual y we want. This is not the Hicksian, commodity of y that we are looking for. So now we need to substitute this y in equation, in equation 9. So let's say that this is step 5. So substitute y in equation 9. Substitute y in equation 9. Then what's the equation 9? U bar, equals to xy. So since we are substituting y, let's clean this. So then what are we going to have? We have px of x over py. I hope I'm not too fast. I hope you guys are getting it. So moving on. By having this, for us, we need to open this bracket, which shows that we multiply this by this. And once we multiply this by this, then our u bar now will be px of x squared over what? Over py. We don't have interest in u bar. What we have interest in finding the x commodity, that is the Hicksian of x commodity. So this is what we want to make as subject of formula. So then what's going to happen? Cross multiply first. When you cross multiply that, you have u bar py, and you have px x squared. Divide both sides by px. This cancel this. Then x squared will now equals to what? U bar py over px. Then we need to square root the both sides. So this will give us x equals to the square root of u bar py over px. So now this is now Hicksian function of commodity x. So this is now Hicksian function of commodity x. So Hicksian function of commodity x. Now we now need to find the Hicksian function of commodity y. So in finding the Hicksian function of commodity y, you substitute x in this equation or in this function. So let's move on to find Hicksian function. So that means we are going to have y equals to what? Px of y. Put into the bracket. Introduce that square roots. Then you have u bar py over px. You have this. Now, then what is going to happen? This one has the square root. We cannot leave our answer like this. We can't leave our answer like that. So you can now have, y equals to px, multiplied by, then py also multiplied by, then this one can now be u bar raised to 1 over 2, py raised to 1 over 2 over px raised to 1 over 2. I believe that we understand that this square root is also raised to 1 over 2. Then we can now make it clear because this division using an indices indicator is a negative. So I can now have px raised to 1 minus 1 over 2 because this is px. Because it's px and the sign will give you negative. So you're having 1 minus 1 over 2. Then you multiply this, then you have your u bar 1 over 2. You have your u bar 1 over 2. This one still continues. And this is also division. That means I'm going to have py, in this case, I'll have 1 over 2 minus 1. This is an indices function. So, and in this scenario, you have something like px is for what? 1 over 2. Half minus 1 will give you half. Then u bar 1 over 2. And this one will now give you py minus 1 over 2 because this is 1 minus half. You have minus 1 over 2. So that is what we have. Then you simplify all this. I need to eliminate this negative. Then I can now say I have px 1 over 2 multiplied by u bar 1 over 2 over py raised to 1 over 2. So I'm doing this because I want to eliminate this negative. So since all of them have 1 over 2, we can easily change it to the square root, which I can continue here. which I can continue here. So I'm going to have y equals to the square root of, px u bar over py. So we have that. So this is now the Hicksian function of commodity y. Hicksian function of commodity y. So we have that Hicksian function of commodity. So with this, we are getting the Hicksian function of commodity y. So the another question they can now ask you from this aspect is expenditure function. Assuming the question states that you should find the expenditure function. So expenditure function. So assuming the question states that I should find the expenditure function. So the expenditure function will now be MO equals to Px of x plus Py of y. So this is what we mean by expenditure function. So, and for you to get the expenditure function, that means you have Px. So what's the value that we'll get for x? Don't forget that this value that we'll get for x. That means the square root of u bar Py over Px. Then plus Py. Then what do we get for y? The square root of Px u bar over Py. So this is your expenditure function. You can now go ahead and expand it, because we can still go ahead and expand this further. By expanding it further, in the sense that you having Px, of this one will be 1 over 2 bar, multiplied by this one will also be 1 over 2. This one will also be 1 over 2. And by doing so, the same thing is going to happen to this. Py, have Px 1 over 2, 1 over 2 over Py 1 over 2. You can now go ahead and, because these will eventually give me Px 1 minus 1 over 2, which will lead to me having u bar 1 over 2, P 1 over 2y. I've made it as a linear equation. Then this one too will be plus. Don't forget that we have plus. So what we are trying to do here is to find the expenditure function in case the question asks us to do. So what we are going to have here, let me expand this. This one will now be Py 1 minus 1 over 2 multiplied by Px 1 over 2, u bar 1 over 2. So and with this, we have Px 1 over 2, u bar 1 over 2, 1 over 2 Py. Then we have what? Py 1 over 2, plus Px 1 over 2, plus u bar 1 over 2. So yeah, your final answer cannot be, if you look at it, we have the same variable here and the same variable here. Px 1 over 2, this is also Px 1 over 2. U bar 1 over 2, this is also u bar b. So your final answer for this expenditure function will now be 2 Px 1 over 2, u bar 1 over 2, and Py 1 over 2. So that's your final answer. So we are done with Hicksian 2. We are done with Hicksian 2. And don't forget that under Marshallian, you need to find indirect utility function. You have to find it. Then exponential function under Hicksian, you have to find it. Thanks for watching. Please subscribe, like, and share. Make sure you subscribe. That's very important.